All right. Tonight we'll be discussing about uh, we'll be discussing briefly about EXECVE, and we'll now go on to designing our own super simple shell, a very basic one. We are going to do that by creating processes. We are going to run some commands as well because EXECVE will help us to do that. And we're going to, if time permits us and if I have charge on my system, we'll also discuss about a command called start. So let's start with our EXECVE. So I will be sharing my screen now. All right. So I believe you should be able to see my screen from your own hand. Okay, so I have two terminals, one by my left and the other by my right. So I actually did something. All the codes we've been writing since we started the session, I decided to push them to GitHub. So I'm currently inside a repository. As you can see, it's telling me about my branch to show that I'm inside a repo. You would see a .git directory here to show you this is a repository. So I have a repository, and then there's this guy called shell. You can actually confirm this from my GitHub. So let's see. I will be dropping the link in case you want to check out those ones we've written so far since we started the session. So where do I have my repo? Okay, repositories. Then it's inside shell. Then you can come here, C16. I've actually worked on this before sometimes while we were doing the PLD for cohort 14. Yeah, cohort 14 and cohort 15. So we already have some files. You might decide to check these files or not, but this is the ones we've been working with. I put them inside a folder called C16, so you can come to this place to actually see the files we've actually worked with since we started this session. So I can copy that and paste here, the chat box, so you can go there. So whatever code we'll be writing today, to push them there. So on your own, at your layer, you can also go through the codes to understand them better. All right, so we said we'll be working with EXECVE, right? So I will create a file called execve.c, and first and foremost, when we learn about a command, we would want to check the manual for such a command. So this is the command. It says that it executes a program. Basically, that is what EXECVE will do. It will help you to execute a program, and you can find it in this header called uni.std.h. So it returns an integer data type based on what we are seeing here, then the function name, then with your opening and closing brackets. Please, someone wants to say something. If you are not saying anything, you can mute your mic because I'm hearing feedback. Thank you. So it takes in 3 arguments. The first one is the path name, which is a const character pointer. This const is just telling you it's not something you can change. It's a constant. A character pointer means a string, right? So it takes in a string as the first argument, which is called the path name. The second argument is it's also a const character pointer, another string. Okay, no, this is an array of strings because this guy here is an array. Then this is a character pointer telling us it's an array of what? Of strings. That means the second argument it will be taken will be an array of strings that will be passed inside it. Then the last one is also an array of strings, but here it has envp, which in this case could be the environment part. or something like that, or an environment variable, something related to that. But our focus tonight is on the first one, which is the path name, and the second one, which is the array of strings. So basically, the first argument you pass here is the absolute path to the file you want it to run, or the relative path, depending on where you are running it from. So that's what you are going to actually pass here. You're going to pass the path to that file. So EXECVE will be able to see the file you want to run. And the next one is other commands that you would likely want to execute with this your executable file. So right about now, we'll just demonstrate how this would work, and we'll see how we can relate it as well to our shell. Another thing we need to note about this guy, okay, yes, it says path name must be either a binary executable, that is an executable file, or it can be a script starting with a line of the form # then your interpreter. So that means you can use EXECVE to even run your bash scripts, or maybe your Python scripts, or any other script we have. As stated here, the first line of such a script should have this interpreter. Basically, EXECVE will help you to run a file which is maybe a binary executable or a script. And you know that our shell has to do with commands. Most are binary executables that we can find in our bin directory, isn't it? And when we run such files, that is we just playing around with files. The same thing here. The main thing that is running those files is this particular system call called EXECVE. So it says it returns an integer, right? So let us actually check the return value of this particular guy. Return. Okay, yeah. It says that what EXECVE does not return on success. It says that if it is successful, then it would not return anything. But what if it fails? Is it going to return anything? Let's see. Did they put it here? Okay, I don't think. Okay, the return value. It says on success, EXECVE does not return. But if it fails, that is on error, it is going to return -1. So the integer value, as stated up there for the prototype, basically means that it is going to return something when it fails. But if it doesn't fail, then it's not going to return anything. There is also something else about EXECVE. It says that it causes the program that is currently being run by the calling process to be replaced with a new program with newly initialized stack, heap, and initialized and uninitialized data segments. These guys are basically telling us about the memory storage of a C program, or the way the memory is managed. We have the stack memory, the heap, and everything. It's now saying whenever a particular program or a process is calling EXECVE, by default, EXECVE is going to take over such a program. It says EXECVE. Please, you can help us mute your mic if you are not speaking because of feedback. So the audio of this particular recording will not be bad. It says that it is going to replace the current program that is running, that is the program that is currently running. Let's say we have a main file here. EXECVE is going to, when you call EXECVE, it is going to take over such a process, that it is going to take over the memory of the process. Basically, EXECVE is going to take control. It's going to get loaded into the stack, heap, memory of such a process. And if it is successful, we said it's not going to return. So basically, when you call EXECVE and on success, whatever commands you have after it will not be executed. Let's show this practically, what we mean by EXECVE taking over a calling process. So I have my stdio.h, because I don't know if I will be printing out, so let me include that. Hash include, and I'm going to include the prototype that I have here, which is my uni std.h. Please, if you have questions, you can just drop them in the chat box, so I'm going to see them. So return 0. Okay, I think I should increase my font a bit here. Okay, so now let us the argument it is going to take in 3. The first one is the path name to the executable. Let's say we want to run a command called bin/ls, or maybe bin/bin/ what do we call it, pwd, all those bunch of executables that are inside our bin directory. We can pass the full path here as the first argument to our EXECVE. So let us print out something to be sure that it is working. Let's say print out before calling EXECVE. Then you might want to print out a new line. Then you might want to call EXECVE at this point. Then you want to pass in the full path, right? Because it takes in a string. So you want to pass in the full path. We have it in our bin/. Let's say we want to execute ls for it to list out the working directories. Then the second argument is what? It's an array of strings. So you might want to come up here and declare an array of strings that you want to pass into EXECVE, right? So we want to use an array of strings. So let's say normally these strings are supposed to be gotten from your get line. They're supposed to be gotten from your get line. So let's say I'm saying get let me use underscore get line. Like, you use get line to read from the buffer. I'm just trying to relate it to our simple shell. So the first argument you want to pass here should be this guy, right? So we have to put in our executable /bin/ls. Then the second one, because we said it's an array of strings, so the second one, let's come to this place. It did tell us something. It says argv is an array of arguments, which is the first one, right? This guy. Okay, no, that's the second one, argv, which we are trying to actually write out now. This our argv, because that's what we want to pass here, but I'm using the name getLine. Now I can use any name provided I'm renaming my variable. I don't have to be rigid with what I have here. So it is telling us something about argv. It says that what is an array of argument strings. Like I said, the arguments that you want to run, or whatever command that the user wants to run, that the user is entering from the command line, you have to find a way to store them inside an array of strings, something of this nature. So it says an array of argument string passed to the new program. By convention, the first of these strings, that is argv index of 0, which is this guy, right? I'm using getLine for mine, but it's saying getLine index of 0 now should be what? The first of these strings, that is argv index of 0, should do what? Contain the file name associated with the file being executed. So it says that what? It should contain the file name, which is this particular guy. My ls should be, by convention, should just be the first argument that I have to pass it here. So we have to specify the full path of such a file that I want to run. So if I want to add other optional parameters here, I would also indicate, let's say I want to run ls-l, then I will pass in -l right here. Then this guy should be null terminated, because an array of strings, how will your EXECVE know when to stop reading whatever you have inside this variable called getLine? So I will need to do what? To terminate it with null. So I'm going to type in null here and then end it this way. So here I have an array of strings. This is the first string, this is the second string, and this is the third string. But this obviously is null in itself. This is null. So I'm running this command called /bin/ls with this flag called -l. So basically, when you call EXECVE on line 11 now, you pass in the particular file you want to run, that is the path name here. As we can see from here, it says we pass in the path name. Then the next thing is what is the array of strings. So EXECVE is going to run this file, then it's going to loop through this guy, start from an index of 1 and start checking the arguments you have passed to what, to this your it's going to check the argument you've passed into this your path, that is the path to such a file. So you're going to type that EXECVE, but this time we are using what, get line, and the last one says what, this our envp is also an array of strings, but right about now most times they do put your the environment variable at this third place, but now we are not using our environment variable for this particular demonstration, so I would want to pass in null here to show that it is empty. There is actually nothing there. And like we said,
Sorry, Mr. Samuel.
Yes.
On line 6, can you correct it to curly brace, the ending?
Okay, thank you very much. Thank you. So let us check the return value of EXECVE again, so we know how we would handle the return value. Where do I have that? Okay, it says that on success it is going to return, it is not going to return, but if it fails on error, then it is going to return -1. So I might want to declare a variable at the top here and say int execv rv, that is the return value of execv, and I can initialize it to, let's say, 10, because I know if it fails the value is going to change, right? So I'm now going to say execv rv, that is return value, equals to this guy. Then I can now set a condition here and say if execv rv equals to what, -1. So I want to do whatever is inside this my if block. I would want to print an error message. I can use my p error to print an error message to the standard output and say error. I just print the error to the standard output, and I might want to exit too as well. I think yesterday we used exit underscore failure bar, something like this.
Yes, exit underscore failure. Yeah, like that.
Okay. So I might decide to exit. It depends on you, or it depends on what the task asks you to do. That's what will let you know how you should handle when EXECVE fails. So we are checking here. If it fails, then this would be triggered. But if it is successful, then of course it says it won't return anything. So I might want to print out something here again and say EXECVE has been called. I print out something like this, then a new line. Okay, what happened there? So my print statement, my printf statement here is just saying EXECVE has been called. So let us try and run this file now. Let us see. We have an array of strings here. Then we pass in this command /bin/ls-l, then null. Then we set this variable to 10. Obviously you can set it to 0. I'm just giving it a random value of 10. You can set it to any particular number you feel like, or you might not even initialize it. It's not compulsory you initialize your the return value of your EXECVE. And here it is printing before calling EXECVE. Then here it is going to execute this command called /bin/ls. Then with this -l flag, how will it know I have a -l flag? Because I pass in get line here. So it is going to check through this particular array of strings, and it's going to execute all the commands we have there one by one until it hits this guy called null. So it's this line is just basically checking the return value, and then it is printing an error message. Then it's going to exit. Then this my printf is saying EXECVE has been called, then return 0 to terminate my program. So let me save this file. I should have EXECVE here. Okay. Okay, that's cohort 16. EXECVE. Do I have it here? No. Let me see. I'm currently inside which directory? Oh wow. So let me move EXECVE inside 616. Okay. So I want to see the inside 616. This is the particular directory we created. Okay, I should have it here now. Good. So I want to gcc EXECVE. Then I want to save the output inside O. No, it should be inside E. Yeah, just say something like E. Okay, I have a lot of errors. Okay, I think I didn't terminate this string. What again? It says expected expression before. Let's start from the first one. Line 11 says missing terminating character. Line 11. Yeah, I didn't terminate my bin/ls. So that's the first error from there. Then okay, I think that's the major error affecting the whole code. Yeah, okay. So let me rerun. We still have another error. It says that what implicit declaration. So I need to include where is my exit defined? Does someone know the particular header where we have our exit defined? stdlib, right? Standard library. Okay, yeah, it's told me to add the standard library. Okay. Alright, so let us rerun our file. Okay, we are running now. And let me do ls before I run my executable. So I want to run this file called E. So I'm running E, and then it says before calling EXECVE, which is my line 11, right? Then it executed everything I have here, that I have inside my get line, my array of strings. It executed everything I have there, which is my bin/ls with my -l flag. So if I should run bin/ls with my -l flag right here on my command line, I'm going to get this same output I have on my screen. So I'm going to run that /bin/ls -l. You can see 156, 156, the same output as when I'm running it on my command line. So this is just telling us that we actually have a function that can help us to run commands, meaning that when I wrote this command on my own terminal, it was EXECVE that handled it and it printed it out to standard output. The same thing is happening here, even though I'm doing that inside my C file. But of course, in a real life application, you are not going to add code commands like this. You should have a way to get them, and you pass them to EXECVE to do whatever you want it to do. Do you notice that it says if EXECVE is successful, it's not going to return? You can see my statement before calling EXECVE, I have it, but after EXECVE, I do not have this particular line 21, because we discussed that EXECVE on success is going to take control of the calling process, and anything after where it executed successfully will not get executed, meaning that the program terminated right here at this point. EXECVE is not going to return back to this process. It's going to take control over the process, take up the memory of the process, and it's going to terminate. So that is why we do not have other statements in our EXECVE. We do not have it actually executing. So if we deliberately make our EXECVE to fail, let's say I'm passing a bunch of stuffs here, we know it is going to fail. Let us see the type of output, and let us see if it is going to execute line 21. So let me recompile my file, and I'm running my executable, and you can see it says before calling EXECVE this, and it's printed out my error message, which is this guy. But then it didn't execute this because I already exited from inside my if condition. An exit is going to terminate your program. So let me remove this, my exit, comment this line, rerun my file. The reason why it is stopping here is because I exited. That is, if it fails, just exit. Exit is going to just terminate the whole thing. So you can see before calling execv, which is what, line 11, and this error message, no such file or directory. This is the error message. You might be surprised that where is this other error message coming from. That one is actually inbuilt for execv. It is an inbuilt error message. If it fails to find an executable, it's going to give you this inbuilt error message that no such file or directory. This particular error we have here is our own p error. That is, we are actually printing out an error message to the screen. So we're having two error messages, the one we wrote manually and the inbuilt error message from execv if it fails to find a file. Then the last statement here says that what execv has been called, which is our line 21, and then our return 0 statement was it, which obviously ended the whole program. So basically I'm just trying to tell us that if execv fails, we can undo that, but if it is successful, then it is gone. It is just going to take control over the program and the program will end. Do we have questions? Because I could hear the sound. Okay, yesterday's recording, yeah, I did say on the group that it went really bad, so I couldn't upload that on the that is why we are taking a recap of this particular execv. Normally we are not supposed to discuss about execv today, we should just move on, but that is why I'm taking my time to go back and discuss execv. So you have a question, Kester, can you ask your question?
Good evening, everybody. Thank you very much for the time. I believe we can hear me.
Yes,
Hello?
we can hear you. I can hear you.
Okay. Looking at the argument you passed to execv using the get line, the second argument is -l. Does it mean that that dash is not part of our delimiters? Because if we use, I believe that -l is part of what we are going to get from get line, the command there. Hello?
Okay, you mentioned something about a delimiter right now. You are saying is the dash, the hyphen, not part of our delimiter? Is that what you are saying?
Yes, sir. Yes, sir.
Okay, that if you want to actually delimit the string. Now looking at the output, let us check what I typed here manually. What did I do? I did my /bin/ls. I'm actually highlighting a part on the right side of my screen. So if you want to tokenize or split these commands into different segments, what do you think you can use to actually tokenize these commands? Would it be recommended
Spaces.
exactly? You have to use your
Space.
space because here is a single string, which is this guy, and the other one is also another string. What is separating them? It is your space. So basically, you would want to use a space here to actually tokenize the command. Your -l is an optional flag that can be passed to an executable called ls. If you do man ls, you are going to see that you have a lot of optional flags you can pass to it. So basically, execv, or should I say this executable called ls, understand what -l means when you are passing it to it. Execv is going to handle that for us, running the executable, passing in other arguments. You can still include other arguments here. It's not only -l. You can add as much as possible arguments here. You can even decide to, a lot of stuff. You can say you want to list in a long format a particular directory. Do I have a directory here? I do not have a directory here. Let's say I want to create a directory now, say test, and then inside test I want to touch a file called test/file1. So I'm creating a file inside that directory, then let's say file2, then let's say file3. So when I ls my test, you are going to see I have a lot of files there, right? Just 3. So I can decide to list out what we have inside test right here. This is bin/ls, list in a long format what I have inside test folder. Then when I do something like this, when I save my file and I try to recompile, okay, it is still going to fail, Abby. Yeah, let me remove this one so it will not fail. Okay, and then I'm trying to run my command again. Okay, my executable. It says that what invalid option. Oh yeah, the forward slash should be after the test to show it is a directory, because this is the way I listed it here. I did ls test, I didn't say ls forward slash then test. So I want to rerun. It's still telling me something. It says that what invalid tab size est. Where is the est? Did I not save this file? ls minus l. Let me run on my command line. ls minus l test. Yeah, this should actually work. ls minus l, then passing in your test. Let me recompile my file. It's giving me an error message. Minus, the error message is even coming from here. It says invalid tab size est. Where did I add the tab size here? This should actually work. This should actually work.
Is truncating the capital T.
Let me save my file again. Oh. Okay. I think I know what is happening. It is running this command. I didn't pass in the full path to this file. Let's see. So I need to copy everything I have here. You understand what I'm saying? I have to copy the full paths because it is running. I believe it is running this file. Let's see. So let me paste this. Then /test. So list in a long format what we have inside home, vagrant, like up to the last one. So I'll put a forward slash there. So let's see. Let me try and recompile again. It's still telling me invalid option. Where is this flagging me now? Bring ls minus l /home /vagrant simple shell test. But then this is supposed.
Is there? Are you having a comma after the minus l -l?
Oh. There should be a comma there. Yeah, you are right. There should be a comma there. Okay. Let's try and save again. And let's try and rerun. Okay, it is now giving us what we have inside test. But in a long format this time around because we use our -l flag in a long format. Okay, let me remove the absolute part and let me see if it is still going to work without specifying the full part. Maybe it's going to run our command as if it is running directly from where we are calling it, which is this particular directory. So let's see. And then I'm trying to recompile my file. It ran without errors. Okay, yes, it still worked. So the problem was the comma then, not the absolute part for this particular guy called text. So the problem was the syntax error that I was having after my -l flag. So basically this is just showing us how EXECVE works. If you pass in the second argument, which is the array of string, it's going to read it one by one. And here for the first argument, since these two are the same, so you can just pass in an index of 0 just like we saw from the manual, right? You can just pass in an index of 0 here. You can say something like underscore get line, then your index of 0. You can pass that in and try to save and rerun your file, and let us see if that is going to work. You can see it still worked. So you can manually type in the full path to the executable as the first argument, or you save it in a variable, then you pass in the variable name for it to work. Now, looking at this code, if EXECVE is actually successful, other parts of the code will not get executed. And this we discussed when we were discussing about how we can create processes. Basically, the idea behind this is that anytime you want to use EXECVE, do not use it in the parent process. You have to create a new process. So when you create a new process, you are going to call EXECVE inside a new process, and if it is successful, it is going to terminate that new process. Then you can now use your parent process to continue running the other parts of your program. So that's basically what we are going to employ. If you want this to be printed out to the screen after EXECVE has concluded or run such a particular command. And who can remind us how we can create processes? Briefly.
We
By using for.
Okay, we are going to use the fork.
process ID.
Okay. I'm coming. I want to check my recording. Did it stop? Okay. I'm still on.
Mr. Sam, my question is not finished though.
Okay, what's the other part of your
Before we
question?
go into the second part of the question is relating to the other argument we passed. The parts of the file we want to execute.
The part.
Of the
Which
file
is
we want to execute.
this one.
This one is hard coded.
Yes.
Good. If, like, let me use my system for instance. Going through the part I have on my system, I have user local sbin, user local bin, then user sbin, user bin, then /sbin and /bin. Which of these parts now am I going to be running my program?
Okay, don't worry. We are still going to get there. It's part of what we'll be doing tonight. So when we get there, then maybe our question will be answered. I believe your question will be answered when we get there. So for now, let's continue and let us create a process. Where should we even create the process? Since let us create the process right here. Let us create the process. So let us declare a variable with the data type PID underscore T so that it can store whatever this guy is returning. So let us declare a variable called for return value. Oh, what did I type there? So then we can now say fork return value is equal to, and we'll call the fork function. It is void, it takes in no argument. So basically here we are creating a new process. So we can now go ahead and start doing all the conditions of checking if it is successful or not. That is, if fork return value equals to a negative number, then it means it failed for the parent process, that it couldn't actually create p error. It couldn't create such a error creating child. Let's say error creating a new process. By default, your p error would add a new line, so I don't need to put a new line there. It's going to add a new line by default, I believe. So it says error creating a new process, then you can decide to return a negative number just to show an error. Then this condition will be checked for the parent process. We've done all these things before, so I'm not taking my time to explain and do a lot of explanations. So after doing this, we can now write another condition to now control either we are in the parent process or in the child process. We already know that it is going to return 0 to the child, isn't it? So we are going to say that If the return value of this particular fork system call happens to be 0, then that means I'm in the child process. I can now go ahead and call this guy, because obviously I'm creating a new process just so I can run where do I have EXECVE? No, my line 16, I should take that off. My line 16 should not be there, it should be inside the my line 16 should be here. Yes, line 16 should be there. So I'm going to take line 16 off. We do not need that in the parent process, because if it is successful, it is going to terminate the parent process. We want it to be successful inside the child process, which is what this condition is going to be true for the child process. So when it is successful here, it's going to terminate this child process. Then the parent process will now execute the other parts of the program. So that is basically what we are trying to do here. Okay. I just want to make it a bit readable. That's why I'm adding all these indents. So this condition is basically checking for that. Then we can now have our else statement here. And then other parts of the code will be executed from here. But then you remember what we have to do, right? We have to wait. We have to use our wait. Then we can pass in the address of wait status, like that. We already did all these things, so I believe we already know them. So I have to go and declare a variable at the top there called wait status. Then I have to use the necessary headers too as well, so I will not have an undefined implicit declaration of any function. So I have to use my sys types.h, then wait as well. Okay, so we've included this and this. So let me assume we've already included all the necessary headers. So basically, for those who have been following this series from the beginning, what wait is doing here, okay, let me explain from the beginning. By the time your control starts this program from your int main, we are declaring an array of strings here. Then we initialize a variable called EXECVE. We created a variable with a data type of PLD underscore T called fork RV. We declared a variable called wait status of an integer type. Then this is our line 15, printing out something to the standard output. Then line 17 is calling a function called fork, which is going to create a process. And it is storing whatever this fork is returning inside a variable called fork RV. It has to return it in a variable of a PID underscore T, because fork system call can potentially return 3 values. 1, it is going to return -1, which is this guy, to the parent if it fails to create a new process. That's if it fails, then it's going to return a value of -1. But if it is successful, fork system call is going to return the PID of the newly created process. It's going to return it to this variable called fork RV, which will be accessible to the parent. So right now we are running as the parent. So the parent is getting this value, and let's assume the creation succeeded. So fork RV is going to get a value of the process ID of the child. So this will be false since it's succeeded. This will be false. Then it's checking if fork RV equals to 0, of which I didn't terminate this, of which it is false. So this would only be true. Fork RV will only have a value of 0 when it is in the child process. If it is successful, fork will return the process ID of the newly created process to the parent, and it will return 0 to the newly created process, which is the child. So this condition, if fork RV is equal to 0, will only be true in the child process. But right now we are running as the parent. So this condition is false for the parent. This condition is false for the parent. And if this if condition is false, automatically else will become true, because that is how if else works in programming. If is true is false, then else automatically becomes true. So that is why control will enter this place and it's going to see this wait. Wait means wait till a status change in any of your created child or in any of the child process. So this wait is basically going to wait uh, for the child process to terminate, or when it receives a signal, it is going to trigger again and it will keep running. So on hitting wait, control is going to trigger the child process to start running. The parent process now is now sleeping. It is waiting for the child or any state or a signal change from the child. So control will go back to line 17 and it will start running, because this was the exact point where we created a new process. So the control will start from here, checking this condition. Obviously it will be false, because now as the child process, the only value fork RV can get now, fork RV will get a new value because we are now running as another process, not as the former parent process. So fork RV will now get a value now called 0. Since it was successful, it is going to become 0 in the child process. So obviously this is false, so it is not going to check that, and this happens to be true. Since line 25 is true, obviously else will be false. That is how it works. But then we are not even getting to else part, because inside our if block we called a function called EXECVE, and on success EXECVE is going to terminate the program. But now what is EXECVE terminating? It is terminating this process called the child process, not the parent process that we already put to sleep here. It is terminating the child process. So on getting to line 27, if EXECVE is successful, like we read from the manual, it returns no value. But then it does return something. It is going to return a signal. It is going to return a signal. The signal it would return is now what will trigger wait to start working again. Like we said, wait as a system call is going to keep searching for any status change in the child process or any signal, or if it receives any type of signal. And from the class we did, and we said about 3 things can cause a state change. Maybe a child that was running initially, it stopped all of a sudden, or a child that was maybe was asleep, started walking, it started running, then that's a state of change, a change of state. And other things too. About 3 things can cause a state of change. We discussed that during that class. So at this point now, when wait started executing, the child was running, but a state change was triggered when EXECVE ended the child process. So EXECVE is going to return a signal on success. On failure, to return -1. So when it's successful, it is going to return a signal. Wait is going to pick up that signal and it is going to now trigger the parent process to start running. Therefore, our print statement will now execute, and the return 0 would also execute as well, and our program would end at that point. So I'm going to run this file now with what we've discussed, and I'm running that. You can see it says that what before calling EXECVE, which is our line 35, then eventually it's already inside our parent process or child process here, which is this guy, and then it says EXECVE has been called, which is our parent process. Just to show you that it actually terminated the child, you might have a print condition here and say something like, you can say print f this won't be printed. Of course it's not going to be printed. It's not going to be printed because control is never going to get there. EXECVE is going to just, from here, control is coming back to your wait. Wait is going to trigger the parent process. So you can have something like this. Okay, I think this is even commented. Oh, when did I comment all these ones? When did I comment it? Okay. So I want to save again, and I want to rerun, and I want line 35 not to, you are going to see there will be no noticeable output. You can see the exact same thing, even though I added a print statement here and nothing happened. Why? Because this wasn't even executed. When EXECVE returns a successful value, it's going to change the state of this child, and from here, wait is going to trigger and it will start running. So this is how you can use EXECVE in your program with the knowledge of creating processes that you know. That is why you need to know how to create processes, because if you don't know how to create processes, then this particular concept is a very intricate aspect of our shell program that we need to take to mind. So that's basically summarizes how you can execute or run commands right here on the terminal. Let me just quickly show you something too. Let me create a bash script called echo co. So echo hash exclamation slash bin slash bash, just to show you that something like execv is running me. You know, we said this guy too can run scripts, so I want to change the mode of this guy to u plus x, then echo. Now I can run this guy directly, right? And it's going to say execv is running me, and I can run this guy from my C program here. So I'm just going to modify what I have here. Yeah, I'm going to, where do I have it? Where do I have get line? Where are you again? Get line. Okay, that's line 10.
Line 10.
Yeah, thank you. So I'm going to come here and I'm going to change this guy to what? ./ECHOO. So it's going to run echo without no optional flag. So I'm going to delete that and just pass in null. This is the only thing I want to run. Echo ./echo, then coming here, get line index of 0. This get line index of 0 means what? I'm passing in the full path to this guy, the guy I want to run right here. Then I'm passing in the full string. So basically there is nothing here apart from the full path. So that means no optional arguments. So the same thing applies. Run this file for me. So let me save this file now. Let me recompile. You can see it says before running execv, which is line 15, it says execv is running me, which is this our command, this guy called ./echo. Then it says execv has been called, which is our line 40. Just to show you that execv can potentially run scripts. We saw that from the manual, and it can also run binary files that are in your bin directory, executable files. It can run them, and it can even run a Python script. It can run anything that is a script, and it can run anything that is a binary executable. I think someone has a question, or oh yes, we'll record that. So that basically summarizes all about execv for tonight. About 1 hour gone. Okay, now let us go to the main deal for today. So there is this task that I want us to do. Let's say you are asked to create, just like this particular command now, we should modify this file in such a way that we can run commands, let's say 5 times. Let's say someone asks you, okay, can you run this file ./echo? Can you run it 5 times? Now, how can we possibly run this guy 5 times? Is it possible? How can we do that? We will now come
to loop
again.
over the entire this in 5 times.
Yes. We want to run, in your shell, if you type something like ls, or how will I even put it? Okay, no, don't worry. But then, how can you make this particular program now run this particular file, like let's say 5 times? How can we do that? When we want to achieve something, we should create multiple instances of what?
No, creating 5 child processes.
Yes. And the condition is that you must terminate a child process before you create a new one. It's not that you should create 5 processes and all the 5 will be running at once. Make sure the first one has terminated before you create a new one. That's the condition they are giving us. Create a child process, terminate it, EXECVE is going to run it, then to terminate, then create a new one, run the second command, terminate it, create the third one, like that. How can we do something like that? Let's say you are asked to print out, you want to print something to the screen. Let's say you are using your printf and you want to print out 1, you want to print it out 5 times. How can you do something like that in programming? Will you type printf, will you type it 5 times?
Then you are going to loop now.
You are going to use a
At
what?
point
A loop.
41.
A loop.
Very good. So that's the same thing we are going to do here too. We are going to loop what we have here for it to run 5 times. So how can we do that? Where can we put our... Are we using a for loop or a while loop or a do while loop? Which one are we using?
A while loop.
A while loop. You feel a while loop will be easier. Okay, let's go on. Where are we
Since
putting the while loop?
it's 5 times.
Yes.
Hello. If it's 5 times, even a for loop 2 can do.
Sure.
We'll just create the loop. We'll create the loop at maybe line 16.
Line 16.
Terminate it at 43.
Line 16. So what should I put here?
We can create a for loop.
Okay.
Int I equals.
For I equals to what?
0. Let's start from 0.
Okay.
Okay, I less than 5.
Okay.
Then increment the I.
Okay.
Then we'll terminate it around 43. Let's try that and see. Okay, I think it has changed.
43.
That's after the parent process. Yeah.
We're 43 here back.
44. Yeah.
So I should terminate it here. Okay.
Let's see.
Okay. So let us manually run the program before we try it on the command line. So this for loop is going to start from 0, right? So it's going to enter this condition. So this is where control is going to come true first, because we created the process here. We are still running as a parent. So from here, it's going to come to our child process. It's going to run, and our child process will get sacrificed. EXECVE will terminate that. Then this would be triggered. Then this our print statement would be encountered too. Then before it hits return 0, the next iteration of the loop will begin. So another process will be created. On getting to wait, the child process will be sacrificed. Then going back here, on getting to this place, before it hits 0, it's going back. So yeah, I think this should work. And you can see it is creating the processes here. Where did we call it? Yeah, it's creating the processes here, and the processes are being terminated here. Right before the parent process was terminated, it's going to start another loop. So yeah, you are right. This is going to work. Just to make it even more explanatory, let us put in a printf statement here and say printf child or child %d PID is then fork, no, that's %u unsigned. So that is I comma fork rv. So we want to just print out the child PID of each of the processes. So it's going to say child index of 0, PID is this. Child index of, okay, let me add +1 here. let me put +1. So it will say child 1. So it's going to say child 1 is this, child 2 is this. So child 1 PID equals %u, then fork RV, on and on. All right. So let us so here we can say printf, instead of saying execve has been called, say child %d has been terminated. Then here which other print statement do we have? Okay, that's for that. All right, so let me save and let me run. So because we are going to get a bunch of outputs, let me just decrease this a bit. So let me run. Okay, it says that I'm having an error on line 20. Okay, line 43. Okay. I didn't specify what D means. Okay, so let me rerun. Okay, I didn't even get a lot of output, so let me increase the fonts. So the first thing says before calling execve, which is obviously outside the loop, which is line 15, it says execve is running me, which is our bash script. This is our bash script now, because we are running this bash script, our .4/echo o. Yeah, we are running our bash script. Let me decrease the font here so we can see the full code. So it is saying execve is running me. This is the first execution. It says that child index of 1, that is child 1 PID is this. Oh, I didn't add a new line there. It says child 0 has been terminated. Then this is the second iteration of the loop. See, let me edit this code to make it more. Let me put my new lines there. It's not looking neat. Okay, there should be a new line here. Okay, even before calling so this is before execve is running me child 1. Child 2 PID is this. Where do I have that? Okay, let me put a new line there. Okay, good. So let me save this file just to make the output more readable. That's all what I'm trying to do. The code is still pretty much the same. So it says before calling execve, it says execve is running me, which is our bash script. Child 1 PID is this. Child 0 has been terminated. Wow. I didn't increment I here. I hope you are following what I'm trying to do, right? Like the type of output I want us to get. Yeah, I should even come here and say this one should be a new line. I believe I'm still on the call. Okay,
Yeah, we can hear you.
Yes, you are. Do you need to increment I? I is already inside the loop.
Okay, what my line 43
We are using a for loop.
is doing is that instead of I starting from 0, my I is starting from 0. Instead of it saying child index of 0 is this, a child should be like the first child, second child. There's no 0 child. That's basically what I'm trying to do. It's not that I'm incrementing I. I'm only incrementing what is going to print here, but I is still pretty much the same.
Okay, I get.
Now it is giving me. You can see we created five different processes. This is the first one now. It says execve is running me. Then this child 1 PID. Child 1 has been terminated. Execve is running me. This is the second iteration of the loop now. Child 2 PID is this. Then child 2 has been terminated. This is the third. I'm not even getting it. It's supposed to be grouping the first ones together, the second ones together, but then just know anywhere you see execve is running me, that means another process has started. So this is the first one, this is the second one, this is the third one, this is the fourth one, And then the fifth one, wait to 1, 2, 3, 4, okay, 5. It's because it's regularly grouped, that's why it's like that. So you can see we've just created 5 different processes that is running this our bash script. So little by little, gradually we are moving forward, and we are actually building something. So right about now, let me push this. Okay, yeah, I'll push the codes after we are done. So that summarizes all about EXECVE and what we should actually know about EXECVE. Another thing we would want to know is how we can actually pass okay, the question someone asked earlier will now lead us to a command called start, about adding paths and all that. So that is at this section now. We are going to discuss about that, about the command called start. So there's another command that we would likely use when we are working with our shell. It is called start. So I want to check the manual for that file, and I want to see what that file would do. So I want to create a file now called start.c. Then I think I should include the sys, just like we have from the right side of my screen. Sys types.h. Ideally, I should even have all these guys in a particular header. That is what I should do. Let's see, which file did I do just now? EXECVE. Okay, so let me add EXECVE and pass it inside a file called shell.h. So vi into shell.h, and then let me remove these lines. So I won't have to keep retyping this. I'll just include my so what's the header here? start.h. So let me add that to my shell.h file. #include sys/stat.h, then uni, then start.okay, and types.h. Yeah, I think I'm good to go. So let me vi back into my start and include shell.h. So I can now start my main program now. Because of our time and my battery percent, I would want to be a bit fast. Okay, good. Someone wants to ask a question. Okay, I think it's your network. Maybe someone can reply in if they
Yeah,
can see my screen.
I can see your screen. I think it's
Alright,
network.
thank you. So this is the particular file we are interested in. And what is this file doing? Let's see. It says that these functions return information about a file in the buffer pointed to by startbuff. Basically, it's telling us about the information about a file, and in the context of what we are learning tonight, your start function will actually tell you if a file exists or not. It can basically tell you if a file exists or if a file doesn't exist. If it exists, it is going to print. Let's see. It's going to return, I mean, where's the return value? It should return 0. It says that on success, start is going to return 0, but if on error, it is going to return -1. Even directly on your command line, you can even use start to get the info about a particular file. You can just say start fork.c, and it's going to give you some start isn't working. It says I need to install blah blah blah. I think I don't have that already installed. But then on your own terminal, if you use this start on a file, it is going to give you the information about a file. But I don't think I have that installed until I actually install it with this particular command, which I'm not ready to do right now. But on your own terminal, if you have it installed, you can just start any file. It is going to give you a bunch of information about such a file right there on your command line. So it says if the file is successful, it is going to return 0, but on error it is going to return -1. And it says it gives you information about a file. Come and see some of the information you can get about the file. If you are so interested in this particular function, you can get the ID number, inode number, file type and mode, user ID, group ID of the file, device ID, the total size in bytes of the file. Had it been the start of my command line is working, it is going to give us this. It's going to show us the total size in bytes of that file. Start is going to return that by default. Then, and a lot of things you might want to know about a file. All these things will be stored inside struct start. That is a data type in C, right? We use the struct keyword to create our own data type, and the data type can consist of different data types. For instance, this one is ino_t. This is a special data type. Mode_t is another data type. Nano link _t UID. So you can see the combination of different data types in C. You can actually have them when you use the struct keyword. Unlike integer, that we only store integer values. Character pointer will only store strings. Float will only store floating point values. But when you use your struct keyword, you can construct, that is, you can build, and you can combine a lot of different data types together into a single name, which in this case they called struct start. So basically, let us see how this function is being used. The first argument is the path name. That is the particular file you want to get the status of. In this case, we are using start to see if our file exists or our executable actually exists. Basically, that's what we are trying to do. So you are going to pass in the full path, just like for our EXECVE too. The first argument is the full path. Then you have to pass in a struct start pointer. That is a pointer to a variable of the data type struct start. Basically, that is what this particular function is saying. Okay, sorry, I think I'm having issues with my network. Can you guys still hear me? Oh wow. Okay, so I was talking about this particular data type. It's also another special data type, your struct starts, and I believe it should be defined in one of these, maybe your cstart.h or something like that, because your struct starts contains a lot of data types inside of it. These are just some of them. These ones you have here. Okay, I think this is part actually the, should I say, the prototype or something like that, or maybe some of it. Your struct starts, you can see it has all this in it. So imagine the particular variables it has defined inside it. So you have to use the struct start data type. Then you can now decide to maybe use type def if you so want to type define this guy or something like that. You can use type def, but for the sake of this class, we'll be using our struct start, and we'll be getting the particular info about a file, if a file exists or not. It's going to return 0 if it is successful, and it's going to return -1 if it fails. That is, if it fails to find this particular file specified by this path name. And if it finds this file inside this struct, a pointer to a struct start data type is going to store everything about this file. It is going to store it there. And if you want to access a variable, you need the memory address, so you have to pass in the address of a struct start variable. So it is going to store everything you need to. It's everything about that file that it finds is going to store it there. If you now want to print out the inode number, the st, the time, whatever, the file size in bytes, anything, you can come to your using the dots method, or you use your is it the referencing they call it now, the shorthand method. You use your dash then with your greater than symbol to actually access each of the individual variables that are defined inside this particular guy. But we are not going to do that tonight. We are just basically doing the basics. But I'm just telling you what is capable of doing, because I've tested it out and I've seen a lot of information that we have stored inside this any variable that you declare, and you pass the address there. So for our start now, let us start writing our code. We can declare the struct start, which is already defined inside one of the headers in our shell.h struct stat. This is the data type. So a struct start is the data type. We'll now declare the variable name we want to declare. So let's say the name of the variable is check, right? Let's say the name of the variable is check. So struct start is the data type. Our compiler understands what it means. Then check is now the variable name. So you can say this guy is a compound name for the data type. Both are together, actually, they are together. So doing that, the way we want to construct our program is in a way such that, let's say the name of our executable is struct. Now let's say the name is s. If we do ./s, then we'll be able to pass in arguments to it, or the files that I want to search for. Let's say maybe bin/ls. If I run something like this, then I want it to, I think I actually have a file called /s here. Okay, I was actually expecting an error. We have a file called /s here. So basically what I want you to do is that you should check this file. That means we'll be using our argument count and argument vector to access the arguments to our main. You should check this file, then we're going to pass this file inside as the first argument to our start. Basically that's what we'll be doing. So we have to make use of our argument count and argument vector. Let me man this guy again, so we say the particular arguments we want to pass in there. Would also need to declare a variable here. Let's call it the variable we are going to use to loop. You remember when we did our what's the name of the file again? vi arg c.c. Okay, no, vi, okay, arg.c, not argc.c. Okay, was it this one? Okay, the first one we did, we changed that to a for loop. But the first one, okay, I said the other way we can use to get this is using a while loop, but we didn't implement that. That is, we can use to print out our EXECVE. It's using a while loop. We didn't do that. We used a for loop for this one. In the video I said we can use a while loop. Here now we are not going to use the while loop to get our EXECVE, that is our argument vector. That's what we are going to use there. You remember from the video I said EXECVE is a null terminated array of what? Of strings. So we are going to use that particular condition now to control our while loop. So we'll be using a while loop to get our argument vector that will be passing to our program. That is this program we are trying to write now. So I can write something like while. Now you remember, if you are running an executable, the first argument is 0, which is this guy. This is an argument index of 1. We have no business with argument index of 0. We are checking that of 1. So I need to change my loop to be equal to 1. So I can say while argv. So I need to come here and declare my int ac, because I want to use them int, no, that's an array of strings, character pointer argv. Then yeah, let's just leave it as this. So we have our argument count, then our argument vector. Then I can say while argv index of high, index of loop, sorry, GBI, while argv index of loop. Then I will need to implement my loop, because If I don't do that, it's going to give me an infinite loop. Yeah, so it says that while argv index of high or index of loop, then it should keep incrementing loop. What do we want to do? We want to keep checking. That is, we expect the user to enter the full path to such a file. So we want to keep checking the stats for such a file if the file exists. And remember, we know that start is going to return 0 if it's successful. Checking our manual again, start is going to return 0 if it is successful. I'm sorry, I'm a bit fast. I'm looking at the percentage. Oh wow. So we are saying while argv index of loop, that is index of 1, then going to index of 2, that's what we keep doing. We want to print out each of the individual files that will be entered. So we have to use our start, right? So I'm going to say start. Where's the function? I have to pass in 3 things to it, right? The first one is the path name. What's the path name now? The path name is our argv. So that's the first thing I'm going to pass into my start. Argv index of loop, which is the first argument. The second argument is an address of the data type of struct start. So where's the data type of struct start? This guy. So I need to pass in the address of this guy. So I'm going to say address of, that is a pointer. It needs a pointer to an address of struct start, and I already have the variable here. So I just need to pass in the address. So an address is a pointer by default. So I'm going to pass in that, check. So I'm going to call struct start, then it can return a what? An integer value. So I'm going to say start rv. So I'm going to say start rv is equal to this guy. Then I'm going to check this condition. If start rv equals to 0, that means it is successful. And I can now print out a message to the screen that, okay, printf I can print out that the file is found. What's the file? Argv index of loop. So I can print out my %s because it is a string, right? That's argv index of loop. Okay, I can say this is found. Then do I need a new line? Okay, I might decide to put a new line. So I want to say if start returns 0, that is, if this is found, it is going to check this. These are the two arguments with the path name, which we want the user to enter on the command line, then also the status of the file. It is going to store it inside this variable called check. So if what it's returning is 0, that means it's successful. Then it should print out the %s found, that is, which is our argv index of loop. But if not, then it can print out a message that it is not found. Else printf then %s not found. No, that means if the file is not found, then it's going to print out this message that it is not found. But this guy would work only if you specify the full path. Only if you specify the full path, that is when it is going to work. Then want to increment our loop at this point. So return 0. Yeah. So let's try and run our program. I just saved the file. I believe we all understand what this code is trying to do, right? Before I run it. What's the name of this thing again? Let me check the message. Shell.h basically has all the headers. That's basically it. All the headers that we need. That's why instead of retyping this guy multiple times, I decided to save it in a variable. So now let us gcc our start.c, then -o, then I already have an executable called s, so let me name it st. Okay, ./st. Then I want to pass in the name of an executable called /bin/ls, and it says that what this guy is what is found, /bin/ls found. What if I pass in other arguments, /bin/pwd? That's the print working directory command. It says this guy is found and this guy is found. What if I pass in a file not found? It says ls not found. They didn't put a new line there. So basically you can use your start to find a file. You can see it says this is found, this is found, this is not found. So now if you want to write your shell, the real coding of your shell now, these are like the processes you might want to follow. I'm not saying this is exhaustive, but then you might want to follow this process. The first one is you doing what? Using your get line to read input, right? Then after reading input, you have to use your string talk to split commands. After splitting the commands, you will want to use your start, or no, you want to add, okay, we've not done that though. You would want to add path to find executables. No, you are not adding path. You want to start first. You should start your commands. stat, start the commands to find executables. Then if your start fails, you cannot go ahead to go and add path to that command. That's if start fails, then add path to find executables. Then after adding path, you want to start again to find executables. Only if these are executables, if this passes, or it depends on if it passes or if it fails. It depends. You should know the type of error message you are going to print out. But if it passes, let me just say if start, then you now call EXECVE. You call EXECVE to run. The first one, you use your get line to read from standard inputs from your keyboard. Then after reading from standard inputs, you want to tokenize the commands, maybe into an array of strings or what have you. Before you can use your EXECVE, you need an array of strings. So you should know from here. That's when you start splitting your commands. After doing that, you might want to start the command, because it is possible that your user might enter ls. If your user enters ls, it will not make sense to start adding paths to ls. No, if your user enters /bin/ls, and then you are now adding paths to it again, you are adding /bin/bin/ls, it will not make sense. So the first thing you should do is, after getting the command the user has entered, you start it out. If it is found, you will now pass it to EXECVE. But if it is not found, you will now add path to it, because it's possible the user entered ls. Then trust me, ls, it's not going to find ls, because it's going to fail, right? So if it says not found, you are going to do that in your own program. If it is not found, then you now go and add the path to it, that okay, /bin/ls /ls. If it fails again, let's say I'm using a command, first and foremost I'm passing in abc, not found, then I'm going to now add my path /bin/abc. If it fails again for the second time, therefore you should know such a command doesn't exist or something of that nature. Then you don't even need to pass it to EXECVE, because obviously it is going to fail. If you pass it to EXECVE, it is going to fail. Let's see if our start is going to see the files we have in our current working directory. I have a file called /f, so let me pass that in. You can see it says that what? It says found. So no matter where your file is, start is going to pick it up and it's going to find it. That's if it exists or if the file is actually there and you are specifying the full path. So you can see start is doing a very big job for you. If a command fails with start, you will now go ahead and add path. So if path is not the first thing you had, you would add path only if a command fails after using start to check the status of the file if it exists. Then if it fails, then you now go ahead and add path. After adding path, it fails again. There's no need to pass it to EXECVE. Just print out the appropriate error message and tell the user, just like when I type abc, then okay, this error message is actually a lot, but you might not need to do everything like this on your own shell. So you'll be told the appropriate error message you are going to print to the standard output. So this is just the, should I say, the thought process of how those of you that have been doing whiteboarding for quite a number of time, we are now getting to the stage whereby you have to actually write your own code. You have to implement things based on what you already know. I believe I'm still on the call. Okay. Based on what you already know, this should be the first thing you might want to do. Get the input, then you will now start playing around with the inputs. You split it into maybe the user entered ls minus l, then you should know how you are going to get ls. Basically, the addition of parts will be done to ls. You have no business with this minus l. The only time you pass minus l is when you've gotten to the stage of EXECVE. That is when you will need to get the other commands. But first and foremost, start working with this first guy. If this first guy fails, there's no point in you entering the stage of EXECVE to try to execute a command that doesn't exist. No, you don't do that. You should not execute a command that doesn't exist. Just tell the user, command not found. There's no need to pass it to EXECVE and it will fail. So start is helping you to do the work. Only if start passes, then EXECVE will take it up, because start cannot run a file, then EXECVE will now take it up. I'm not saying this is exhaustive. You can still add your own. This is not all. I'm just giving you based on what I know or based on my own personal opinion. I'm not saying this is how you should that you must be rigid with it or you must follow this process line by line. Please let me okay, I said as regards part, there was something we need to do which we have not discussed, but there is something called paths, an environment variable called path. If you do env on your command line, if you type env and you click on enter, it is going to show you a bunch of environment variables. These environment variables is the third argument we can pass, optional argument we can pass to our main function. I didn't put that here because we've not gotten to that particular concept. I think that our next session on this simple shell series will discuss more about environment variables. But for the sake of the parts we want to do now, that is why I'm talking about these environment variables. So this is it here. The particular one we're interested in is called paths. Where is paths? This is it. Right here. So this guy is called paths, and these paths are actually should I say directories that your interpreter is going to look through whenever you try to start a file or whenever you try to use EXECVE on a particular path. EXECVE, you are going to pass in the full path. So these are the directories your interpreter is going to look through, and many a times when you check through these directories, you are going to find executable files there. The most common one is your bin. So we have other paths too. So we want to get this path. Basically, we want to get it. So that is what we want to get. So by now you are like already anticipating what we want to do. This is it. If a user enters ls, right, as the command, we want to add in front of the ls, we want to add /home/vagrant/ed dot local slash bin. We want to add it to such a command, something like /home slash local, like whatever is here, we want to add it to it. After doing that, we want to come and add this one again. Now this our parts. There is something that is used to split the individual parts. The first one is this. The second part, it has a colon separating the first part from the second part. That is one beautiful thing about this our parts environment variable. After this, another semicolon is separating this part from this part. Now where is our slash bin? Our slash bin should be, let me show you, slash bin. Okay, I think this should be it. I should see a slash bin here. I think, is it USR local bin /bin/ls. Okay, I can't see that right now, or possibly this is it, but I'm not so sure. I'm actually looking for a slash bin, but it's not part of the parts that I have here. But basically, if we want to tokenize this part string now, what can we use to tokenize it to get the individual parts? This is a question. Oh.
The colon.
Eh?
The colon.
Exactly.
We use the colon as a delimiter.
We can use the colon, and when we use the colon, we are going to get the individual parts. So that's exactly what we are going to do right now. In fact, let me even create a new file. Let me call it parts.c. So I want to include, I wouldn't know how many of the headers I'll be using, but let me just include everything. Then I would need to use my string talk to, so I didn't include my string.h in the shell.h, so I want to include it here manually. So we can go ahead and since we'll be doing we would want to store the command somewhere, whatever string talk is returning, and also we want to use our start too. So I have to declare another struct start, and I can decide to name it full. No, what should I name it? Okay, let's just name it. What did we name the other one? Okay, let's name it st. Struct start st. Then I want to declare an array. Let's name this guy store. A character pointer. So this guy is going to store whatever string talk is returning. So I can say it is equal to null initially. I can say this guy is equal to null. Then we'll need to loop through as well. So to get our environment variable, which is our path, we'll need the help of a function called getEnv. That particular function can be used to get our environment variables. Let me see. Man getEnv. Is it here? Man getEnv. Okay, yeah, is in this particular library, and it takes in a what? The part name. That's a character pointer, which is a string. So it returns a what? A character pointer. It returns a string. That is a pointer to where the string is actually starting from. So if you want to get env, I'm just going to pass in whatever I want to get, which is what? Part. Part is the name of the environment variable. So it is going to return a pointer to the location where part starts from. Let me this is it. I want to get part. So it's going to return a pointer to this location equal to when I try to start printing whatever getEnv returns, it's going to give me everything I have here. So let us try that. Let's say store equals to getEnv, then part. So let us try to print out store. is percent %s.
The main function.
Okay. Oh, thank you. Thank you. Int main. Okay, we would need those agree and exec guys. So, like I said, we'll be using them just like we use it for start. ARGV. That's character pointer ARGV. So then okay, no, then this here. So we're having our printf here and this. So I would have my return keyword here. Okay, so let us just confirm every line of code we are writing just so we are sure, because when we are trying to write complex
Mr.
code.
Sam,
Yes,
hello.
I
I
can
want
hear
to
you.
ask on our line 7,
Okay.
that struct, that data type, do we need to add the definition in the header file or the
Yeah, this particular
on the
variable is,
on the shell.c? Yeah.
it is defined though. It's already defined here. I think inside types dot whatever. Uh, no, it's man two starts. It is already defined inside starts dot h. System starts dot h. It's already defined there, and we've already
Okay.
included it
Okay.
inside our
Okay.
shell dot h. So our compiler knows
Okay.
what struct start means. It knows that.
Okay.
Yeah.
Thank you.
So we want to
Somebody
confirm.
was also asking for the content of shell.h. Somebody wanted to see it
Yes, I already
properly.
Don't worry,
displayed that.
I've gotten it. Thank
Yes.
you.
So gcc parts dot c minus o.
Sorry, you are going to have an error. That's line 12. You did not pass the store.
Okay. Thank you. We want to print out store. Thank you for that. Do we have an executable called p? Okay, we don't have that, so I can gcc parts dot c minus o then p dot slash p, and it says that what store is this. You can see it's printed out exactly what we have for our environment variable that is called part. So that's how we can use get env function. You can see when we echo what we have inside parts, it's basically the same thing as what we have here as well. So now, okay, this was the slash bin I was looking for in the other time. I said there's slash bin. You can see a colon to show you that this guy itself is a part. Now, going with what we have here now, we can now decide to do what? To tokenize, because that's what we do, right? And we need to be tokenizing one by one. After tokenizing each of this string, we would want to add the command the user has entered. The user enters something like ls, which we'll be getting with the help of our ARGV. So when the user enters ls, right, we are going to add our path to that ls. Normally in your shell, you would want to start this file first. If it exists, you will now no, if start fails, if you start this guy and it fails, then you will now add your path. But we are not doing that for now. We just want to show us how we can actually add paths to any command the user has entered. So we just do that, and then we'd want to declare another variable. Let's call it int. No, it should be a character pointer. Let's say store 2. Let's say equals null. Then now let's come here and say store 2 equals to what? String tag. We want to tokenize what? Where's the string? Okay, we are tokenizing index of 0, index of 1. We are starting from index of 1. No. Sorry, we want to tokenize the this guy with a colon. What's the name again? Our parts.
Store.
Yeah, that's
Store.
our store. Yeah, that's our store. Thank you. So we want to tokenize this guy with a what? With a colon. Yeah, I think this is what we should do. This is what we should do. So now we want to tokenize. After tokenizing, it's going to return inside store2. It's going to return the first one. After returning the first one, we'd want to enter inside a loop now. So we can use a do while loop, because we know at least the environment variable, there will be at least one part there. Since we know this loop is going to run at least once, it's now possible that after running for the first time, there's no more token there. It's possible, but at least there will always be one environment variable at least. So in this case, a do while loop will be best, because that is what a do while loop is for, when you know that it is going to run at least once. So we can use our do keyword, something like this. Now, am I still on the call? I heard something like, if I just came back now. Okay, I believe you can still see my screen, right?
Yes.
Thank you. So the user enters ls, and we already have the part we want to add to it, which is our store2. So let us declare another variable again at the top, because we need to store the addition of ls. We want to concatenate. We need to store the addition of ls, and this our first part that we are what do we call it, that we just tokenize. We need to store the two of them in a variable. So now we need to declare another variable. Let's name it let's say full part now, because it's going to be the full part. Let it be an array. Let's pass in the size of, let's say 40. Let's assume, or can it be more than 40? Let me pass in 50. Let's just say 50. It can't be more than 50. Yeah, let's just do something like this. Let's do something like this. So a do while loop, the first thing we'd want to do, our store2, which is what this time around is our path. What if we store this guy? Good. So the first thing we need, let's say our path now is /bin. Our path, let's say the first token is /bin. We'd want to add this guy and append to the end of this /bin. We want to append, the first thing we would append is a slash, followed by the command the user entered. This is the first one, what our string talk is returning. This plus / plus what? ALX index of 1 or index of 2, and on like that. So you can see the process we are following. The first thing is what? Whatever string talk is returning, plus a /, then plus the argument. So the same thing we are going to do here. First and foremost, we need this guy, right? So we can just use inside our string.h. That's why I added my string.h. We can copy this guy, our store2, which is the first token. So let's just copy that guy. We can use a command called string copy to do that, strcpy. So let us check how string copy works again. Command strcpy. String copy, it says copy, it will copy a string. So the destination and the what? Source. So the destination, where do you want to copy it to? We want to copy it inside what? Full path. Then what's the source? Store2. Probably. Let us confirm this. Let us confirm everything we are doing. We would need to confirm. So let me print out full path. Full path is %s, then new line, then full path. No, capital P. Okay, no, double L. Okay, so let me just put here, just terminate this condition and say while 0. It is going to just end it. It will not be an infinite loop. So let me just do something like this, just for this to run once, right? Just to confirm. Let us see if our full path will now have the value of the first token. Okay, I don't need my line 12 again. I will just delete that, or yeah, we just use that to, no, I don't need my line 14. I mean that has been confirmed already, so I don't need that again. So let me recompile my file. No errors. And it says full path is what? /home /vagrant /localhost/bin, which is the first part we need. Very good, we are moving. So after doing this, we need to add the slash in front of it. After getting the full path, we need a slash. So that's what we now do. Where are you? Okay. So after doing this, there's a particular command, string cat. You can use to concatenate strings. Let us check the manual for that as well. strcat. So it's what it says, concatenate two strings, the destination and the word the source. Good. So strcat full path, then the source. This time around we want to add our slash, which is a string. So you have to do something like this. I want to add to my full path, which is now the first part. In this case, whatever string tag is returned, I want to add this to it. Then if I should print this out to the screen again, we already know the type of output we should get. So let us confirm as well before we do the final one. So I'm having string cat is now on my screen. So I want to recompile my file. So it says full part is this. It says full part is now this. Now the slash is in front of it. We are moving forward. We are moving forward. So what do you think we can do now to add our argument vector? Can someone tell us what we can do?
Okay, we'll have to argument vector, which is a string too. So we'll have to append the %s.
Like from this output,
We'll still concatenate the
22.
argument vector.
Yeah. So we'll still concatenate it here. That's true. Concatenate that.
Then we'll now pass it to EXECVE.
No, we've not gotten to that stage yet. We've not gotten to. I will say full part like this, right? ARGV, right? Then let's assume our command is only taking the first one. Like if you want to run it, something like /b, you just pass in ls. That's the only thing it can run. As simple as that. So we have to manually add code the first index, right? So I will terminate this, and then I can decide to print again. Oh, I'm having some other unnecessary stuffs there. In fact, this printf should be very close to this guy. Okay. So string cat this. Okay. Let me run my file. ls. The first one says full part is this, the second one says full part is this, and the third one is now giving us the real full part, not the fake full part. The other ones are fake, but this is the real thing that we need at this point. So therefore this guy, now we can now use this guy to do whatever we want to do. But like I said, before you start adding parts, you should check if it actually exists. After checking, then you can now go ahead. That's if it fails. If it fails, then you can now go ahead to add your part and check again. If it fails, then you print out the appropriate error message. But for this case, we are just checking and experimenting how we can actually add parts to simple commands like this. If I run again, I'm passing pwd, then we expect it to actually give us something of that nature as well. So right about now, we will now
I have a question.
okay, what's the question?
Okay. all these functions we have used, they are the system inbuilt functions. Are we going to use the ones we created, or these system inbuilt functions are permitted?
Okay,
That's
you are
we have
actually
our
obligated to use the ones you created. All these things we've done it before. We've created our string talk. Yeah, I believe, but I'm not sure of string talk. No. We've not done string talk, but we've created string copy, string cast. We've already done them when we're doing pointers, array, and string. These guys are very related to pointers, so we've already done the duplicate. You can check your GitHub from there. You're going to see you've already done it. Your string talk, your string copy, string cast, then even your string len. We are still going to use everything.
duplicate the length too.
String len, everything. You have to use your own and not the standard ones. But for practice, you can use the standard ones. You will check the output, then you can now maybe push your code to GitHub. If it is checking, then you can now replace those standard ones with your own and check again, because at times when you were doing your project, maybe it has a minor issue or a minor error and you might not know. So it is best you check first with the standard ones. After checking, if it checks, then you can now replace them with your own. So if you are getting issues, then you will know that the problem is from your own functions. Unlike when you push your functions initially and it is not checking, then you started to modify a part of the code you are not supposed to modify. You do not know that the problem is from the functions you are using, not from the real code itself. So what I would normally do is I would use the original ones, the standard defined ones. I would know those ones can never fail. Then if there's any error from the checker, therefore it is from me, not from the standard ones. But if the standard ones are checking and my code is working, then I'll now replace it with my own. If I'm not getting a lot of issues, then I know I need to work on my own functions. Therefore I have an issue somewhere there. I encountered that error while I was using my own user defined get line, and when I used the standard one, that is this one, it was working. But my own user defined get line, I was get env, I was having bugs, so I had to go and remodify my get env so it will work exactly how the standard one is working. So now we've been able to actually do the full part. That's basically it. Then you have to go and use your start. We declared line 7 our start, right? Let me check any minute now. Okay, almost 2 hours. Then now we would have to use our start to check if, right, I want to write the return value of start on a single line. If start, then I want to actually check the full part, comma, then I will pass in the address because that's how to use it. Then this time around st, if it returns 0, this line is calling start at the same time it is checking the condition for the return value of start. That's what this line is doing. Instead of me calling start then saving the return value somewhere, then now using my if condition to check the return value. So I'm just trying to do both on a single line. So I'm just going to print out %s found, right? So a new line. So what's %s is my argv index of, no, that should be my full part now, not my argv. That should be my full part. So let's see. Okay, then yeah, then you can say return 0. Now what we are doing here is this. We want to pass in a command. Let's say we want to pass in a command called ps. Obviously this command is going to do something. Or let's say ls. You want to pass in a command called ls and you don't know if this command exists. So we want our program to go and loop through all these parts one by one. This one is only checking the first part. We've not written our while condition for it to keep looping until this guy returns until string talk returns null. When string talk has tokenized all the tokens, that is the tokens for our parts, is going to return null eventually. Why is it not typing? It's going to return null at some point. So we have to actually have that condition that if string talk doesn't return null, then keep looping through each of the this guy. The only thing we are doing now is it is checking for the first one. We've not done for the second one, third one, on and on until it has exhausted everything we have in our parts, which is what we want to do both in the real shell and also in the real uh and also for this experiment. We have to check through all the parts, all the parts directories that we have. It's not only the first one we check through, everything. That's what we want to do. So therefore, uh I wanted to type return 0 here, and I ended up typing something else. Okay, good. So if it finds the command, then it should print out command found, then the program should end. Then this our condition. What can we put in this our while condition in such a way that it will keep looping until it gets to the end of this our part? What do you think we can write here to change our condition? Because if I should run this file now, it's still going to run once. How can I do it? You should keep running until it gets to the end
While
of this condition.
while store two is not equal to null.
While store2 like this, not equal to null, like this,
Yeah, yeah.
something like, okay.
Or that we can still do while store two because it's going to be a true value.
I can do what?
You can still do while store2. So long as store2 is not null, you can still do while store2
Okay.
and close the
Do you
bracket.
know
What do we have in ARGV? Because we had coded the index.
ARGV is something like this? If I'm running my executable called .4/p, I will just pass in ls, then it's going to use this ls as my ARGV1.
Okay.
Do you know something? This condition
okay.
now is going to become an infinite loop. Do you know why? Because here we called store2, but looking at this condition, the body of our do while loop, we didn't call string talk again. We only called it once. So this condition will always be true.
Yes. It will be true. We're supposed to be calling string talk to append the new token.
Exactly. So it will keep changing the value of store2 until it eventually exhausts the old token. So right here we can just do something like while. Inside our while condition now, we can now call string talk again. We can just say
Oh, that's nice.
store2 equals to strtot.
STRs. Yeah, that's true.
You can do something like this. Then again, we pass in our delimiter.
Delimiter. Yeah.
Then I should append another
So
bracket.
so that
So it will
so
keep
that
changing.
place is going to
It will keep changing. Then I want to use a loop too. I want to have like a variable. It should be printing
no.
full
If
parts index of 0, full parts index of 1. So we know how many times it's looped through. So let me declare a variable at the top here. Int I equals to, should we start from 0? Yeah, let's start from 0. So let me say I need to keep incrementing I somewhere here. I plus plus. Yeah, and then so you say full part index of I, which is index of 0, full parts percentage d, like this, then I comma full part, then the same thing here, full part index of I, no, index of I is this, then I comma this, then the same thing for this guy, I comma this, full parts percentage d, then you should print out percentage s found, that's here. Okay, let's try and see what will happen if we will not get an infinite loop. Let's try and see. So I want to recompile, then I'm getting a lot of errors. The first one is from line 11. It says line 11 is wrong. Okay, equality symbol there. Okay, then it says line 18 is wrong. What's wrong with my line 18? It says false used, undeclared. Okay. Because it didn't read. Yeah, I think I understand what it is saying there. Okay, so let's recompile. Okay, no errors. Then my slash p, I want to pass in ls, and then it printed out something. It started from 0. Then this is the first one. This is the parts. Then this is the part with slash. Then this is the part with agv1. That's for the first iteration. Then it went to the second one. Part again. This is the second part. Part with slash. Part with argument. You didn't find the file, so it has to go to the third one. The third, again and again. You didn't find the file, so it keeps going. It keeps going. Eventually, at some point, our start was able to dictate the file. It's inside one directory called usr/bin/ls. So it's telling us that inside usr/bin/ls there is a file. Inside our usr/bin there is a file called ls there. Now let us write our condition in such a way that let me run this file again and let me pass in abc. Now can you see what happened? I started running from here. It looped through from the beginning to the end. It didn't say something is found. It looped through from the beginning to the end. How can we write this program in such a way that if it can't find a command, that is, if start cannot find a command, it should print out something like command not found? Is there a way we can actually do that inside this our program? Is there a way?
Yes,
After the if, we
wait.
just do this.
If statement, yeah, after the else you give there.
Where?
After the if statement for start full part equals equal to,
Line, okay, inside here, ba?
yeah,
Are you sure? Okay.
yes now, because if start is not successful, if it's not successful, then we'll go to the else statement.
Okay. Let us see. Maybe we are going to detect another bug from here. So if you say this one not found, then it should return, right?
We don't need parts now. Do we need parts? Okay.
No, I'm trying to print
Found not found.
that the file is not found. Maybe if it is /bin/abc, something like this, it should just say not found after searching through the whole part on my system. So I still need to pass in full part. Full part.
Almost.
So let us return and let us see. So I want to clear this now. I want to recompile and I want to pass in pwd, which is the correct command.
It will only work once.
See something. It says that pwd not found though. Let me pass in.
They return 0. They return 0 inside the S. I don't think is it necessary.
It says not found.
The return 0 we want inside the S.
Yes.
It's actually terminating the program.
Don't worry, just beat. Just beat when you come over.
Okay. You are saying I should remove this return 0.
Yes.
Okay. Let me recompile.
It's not supposed to be there. It's supposed to halt. It's going to halt it once.
Okay, it says found. Then now at each iteration it is printing not found, not found, not found. I want it to print not found only once after it has looped through the whole environment path, that is the path variable. It's not that on every iteration it should keep saying not found, not found, because this is actually a bug now. The command is actually somewhere in
Yeah,
your, I should what?
go down to your, just scroll down to your code.
Okay.
Let me see the bottom part of it. Okay, so if this is so you let it go through, or
Yes, it should go through before it
through,
says
let you
not
go
found.
through, or where, yeah, let's take away that sprint from that place.
Okay.
Sure.
Oh yeah, I believe others are still on the call though. This is like a discussion now. I'm throwing it open. Oh yeah, oh we're already sleeping.
Oh, yeah.
Kesta, Obafemi, Olumide, Steven,
Give us the code. Give
Ifeolu.
us the code.
Okay, this is the code.
Mm-hmm.
This not found now is already a bug for us because the command is actually somewhere. This file is somewhere, but it's saying not found every time. So it is stopping only when it finds the file. We want it to keep going until it finds it. Then if after it has
Okay.
looked through everything, it doesn't find the
Can,
file, then it should now print out
can
not
we
found.
can we do something like this?
Okay,
We set a flag,
okay,
maybe like an integer. If
okay,
it's found, let it be one. If it's not found, let it be zero. Then outside the loop, we now check.
okay. So what's the flag? Let's say it is what?
Yeah. So let's start the flag as 0 first.
Okay, 0. Okay,
So when we now, yeah, so if it is, if start is equal to 0, let's
If
let's
it's
put
found,
flag
if
to
it's
1.
found,
Yeah, that's what I'm saying
if
now.
it's
Like if
found,
start
that's inside
equals
line.
0,
Yeah, yeah.
inside
inside
line.
line 28, you should
28,
put,
29.
Okay,
yeah, you should,
And
yeah,
change the
you
status
should
there.
change 1.
okay, to be 1, like this.
Yeah. All right, then in our else now,
No, I think we'll just do it outside the loop. Once
outside.
it's true. Mm.
Yes.
Okay,
So yeah, after there.
Mm-hmm. Yeah.
you can now have another if.
So if flag is
Equals to
1,
0
yeah.
or 1.
If it's equals to 1, you should write found. That means the
It's-
found we've written up, we should take
No,
it
we've
out.
already done that already now. We've already done that one for found.
And we'll
Now
take
what we
it
want
out
to do
from
is not
28.
found.
And we'll take it out of 28.
Yes, we'll not put it down there.
Mm. Just comment 28. Yes.
Okay, and say flag equals 1.
Then print out found.
Okay,
So the entire loop will run. Then to just come and do that last check there. Already by that time flag is equal to 1
then
when it's
else
found.
ba.
Yeah.
But you know the loop is supposed to stop
The loop will
when it
stop,
finds.
alright? Like if we find the the stuff, if start equals 0, the loop is going to
Stop.
stop, and then
Okay,
it will come out of the loop now, and
to
because it's
come
now having flag as 1.
come
Yeah,
and execute this statement.
exactly.
But if this fails, like if this
If
condition doesn't
it
return true,
doesn't,
this is
if
going
it
to be true.
doesn't, exactly.
Okay, okay, this makes sense. Let us try and run again. So let me run with a failing command. uh okay, ABC, and then it says that no,
ABC,
it's still
it
saying
says
found though.
ABC found.
Okay, okay,
No,
okay.
we put the same statement for all of them. Not found.
Okay, good. It says that
Yeah.
what ABC not found. So what if it's a command that is going to find and then it stopped there?
Yeah.
It's not printing
It's
found.
so it's going because of that return zero.
Okay, I can remove the return keyword then. It's not needed, right?
Yeah, yes, it's not
Let's try it out and see.
But without return statement,
it's going to do
It
for
will
all of them.
continue. It will still
Let's put
continue.
it back. Let's put it back.
Mm.
The flag is zero there.
Okay, then we remove it. We remove that comment in 28.
okay.
Yeah, I think it will work fine now. It means the program will now end in 30.
Yes, it will end there. You're correct.
Okay, so we should try again, ba.
Let's
Yeah,
see.
So let's run with a
it's going to
command.
work now.
It says that command found. Let me run with ls. It says found. Now, do you know this code will not run if you pass in the full path like this? You can see it says not found because the the user entered the full path and you are still adding another part. Obviously, start will fail. So that's why I said anytime the user enters a command, you would want to check first if it exists. If it doesn't exist, then you can now go ahead to add parts. Don't just add parts to a command because of the sake of adding parts. It's going to fail and that will introduce a very big bug to your code. So you might want to follow this process of starting a file before you actually want to add your parts. Then if the addition of parts ah if start fails, you add parts, then you start again. If it fails, no, if it's successful, then you add execv. If start is successful here, then you call execv. uh like
Okay,
you don't
sorry.
need to
I
add part.
have a question.
If start, if it's true, then just call execv straight up. If start to find executables,
Okay,
then execv.
okay. One is agreeing straight up because
You
that's the
call
full
it
part.
from there. But if it fails, then you add parts. You start again. If it passes, then you print you call execv. But if it fails, then maybe you can print appropriate error message or something of that nature.
Command not found.
And remember, you should still check for some system commands like exit. There are some commands like this exit. Execv cannot run those ones. I'm not so sure. Commands like change directory, commands like cd exit, there are about 4 of them or even more. The execv cannot run. So these commands, you are going to check for them first and foremost. It's as if my network went off there. Did I go off just now?
For a few seconds.
Did I go off just now? Okay.
For a few seconds.
You did
uh
for a few seconds.
it's actually raining here, so I think we should end the session here because this recording is going to be so awkward because of the noise from my
Thank
end.
you.
So I feel we should end the session here. By the
All right.
next session, we'll come and actually work more on environment variables and how we can play around with them. So I'll be pushing these codes to GitHub just so you can modify them and work around them, and even you can even write your own command in such a way that if you pass in a lot of arguments, let's say ls, it's going to run. Not that it's going to run once. You might decide to write your own and even improve more on what we have here. uh, oh,
All
okay.
right.
Let
Thank
me
you.
stop the recording. Thank you, everyone. Thank you.
Yes, Mr. Hassan, thank you.